Hey, you guys, welcome back. Today we're going to go over the study guide. Let's go ahead and get started. Question number one just says, what is an integer? So an integer is any positive or negative whole number. Any positive or negative whole number. So we're not talking about fractions or decimals. That's actually going to be our next unit, and those are not integers. All right, so write 5 examples of integers. There's literally an infinite amount of integers we could write. So I'll give some basic ones. -5, 13, 22, -18, and 0. 0 often gets overlooked, but 0 is an integer. It's not positive or negative, but it is an integer. The next one, compare the following integers using these symbols. So in case you forgot, we have these 3 symbols. We all know the equal sign. That's everybody's favorite. It's the easiest one. Over here, though, some kids forget which is which. So this is a less than symbol, and I always remember it because it kind of looks like a lazy L. A lot of teachers say that. It kind of looks like an L, and then you kind of like turned it a little to the side. And I realize as I'm facing the camera, that looks backwards. So anyway, this looks like an L, and I always think of it because I can write the word less inside of it. That's how I've remembered it since I was like in the 6th grade when my teacher told me that when I was like 12. So you can write the word less inside. That's the less than symbol. And this one is the greater than symbol. So let's go compare these things. Now, 5 and 25, that's a pretty easy one to compare. 25 is, of course, the bigger one. And we don't really say, we don't use the analogy of an alligator in middle school. We're kind of too old for that. But in elementary school, it is a great analogy to start with. The alligator mouth would be eating the bigger number, all right? We don't really say that anymore, though, because we're a little too old. But it's still good to think about if you're kind of having trouble with these. The next one, -16 and 8. Now, this is where things get a little more difficult in middle school because we have negative numbers involved. 16, if there was no negative sign, 16 would be bigger than 8. But any negative number is always smaller than any positive number. So I always like to think of it in terms of money. Which one would I rather see in my bank account? Which one would I rather see on my Cash App balance? -$16 or $8? I'd rather see $8. So that's the bigger number here. The next one, -27 and -28. Again, it's like, which one would you rather see in your bank account? -27 or -28? I'd rather see -27. It's not that much better, but it's a little bit better. And on a number line, if we drew a number line, we'd have 0 somewhere in the middle. We'd have 27 and 28 way down here. We know 28 is the bigger number. But on the opposite side, the negatives work in the opposite way. 28 is the bigger number, but -28 over here is the smallest number compared to -27. As we go further and further left on the number line, our numbers get smaller. As we go further right on the number line, our numbers get bigger. So let's look at the next one, -15 and 0. Again, what would you rather see in your bank account? I'd rather see 0. And this one, these are absolute value bars. Whenever we talk about absolute value, we're talking about the distance from 0. So the absolute value of -8. If I think of my number line, -8, that's 8 spaces away from 0. So the absolute value over here is 8. The absolute value of this 8 is also 8. No matter where you are on the number line, if we drew a little number line over here, I got my 0. If I had -8 out here and +8 out here, they are both 8 units away, or 8 spaces away from 0, because distance is always positive. So these are the same exact number. So we're going to put an equal sign in there. Let's look at the next one. Name the opposite number. So opposite, that just means the same number except one's positive and one's negative. So we have 3. The opposite of that is -3. We have -8. The opposite of that is +8. We have 27. The opposite of that is -27. We have -19. The opposite of that is +19. We have -100. The opposite of that is +100. So opposites are the same exact number, except one is positive and one is negative. Down here, 0 pair and additive inverse mean the same thing. Explain what they mean. So 0 pair and additive inverse, they are named pretty well. 0 pair, we have that keyword 0. We also have that keyword pair. It's kind of like a pair is 2 of something. So we have a pair of numbers that add to 0. That's what a 0 pair actually is. It's a pair of numbers that add to 0. Additive inverse, whoops. Let me get that thing back in its place. So 0 pair and additive inverse mean the same thing. Additive inverse, additive, that really makes me think of the word add. Inverse means opposite, so add the opposite. Additive inverse means add the opposite. Zero pair are a pair of numbers that add to zero, which are opposite numbers. Because all these opposites we just named, when we add every single one of them, 3 and negative 3, negative 8 and 8, 27 plus negative 27, negative 19 plus 19, negative 100 plus 100, when we add them up, they all give us 0. So that's zero pair and additive inverse. Adding two opposite numbers gives you 0. Let's look at the next one. Complete the following equations by using the additive inverse. So negative 5 plus something equals something else. If we're talking about using the additive inverse, we're going to add the opposite number. Negative 5 plus 5. Over here, negative 5 plus 5 gives us an answer of 0 because they're opposite numbers. When we add those together, we get 0. The next one, something plus 18 equals something. Additive inverse, we're going to do the opposite. Negative 18 plus 18 equals 0. Over here, negative 25 plus positive 25 equals 0. Over here, 128 plus negative 128 equals 0. Add the opposite, you get 0. What is absolute value? Absolute value is the distance from 0. So always think about it on a number line. How far is that number away from 0? How many spaces away are you? Whether you're on the negative or positive side, it's always the same positive distance. Find the absolute value of the following numbers. So the absolute value of negative 8, that's just going to be positive 8. The absolute value of 6, that's 6. And some kids think the absolute value is the opposite number. Sometimes it works out to be that way. The absolute value of negative 8 is 8. But the absolute value of 6 is not negative 6. It's positive 6. So it's just the distance from 0. Absolute value of negative 13 is 13. Oh, and this one looks really difficult, but we just do whatever is inside those absolute value bars. Negative 2 minus 3. We do that keep change method, which we'll get more into here in a second down on the study guide, but we keep the first number the same. We change subtraction to addition and change the sign of the following number. So this is really negative 2 plus negative 3, which is negative 5. And now we'll take the absolute value of that. So we end up with the absolute value of negative 5 is just positive 5. Then over here, the only time that absolute value will ever be negative is when the negative sign is on the outside of the absolute value bars. That's really because this is more like negative 1 times the absolute value of 5. That's what we're really seeing here. We just don't have to write that 1. It's assumed to be there. So this is really the absolute value of 5, which is 5 times a negative 1. This is negative 5. Or a simpler way to think of it, if the negative sign is on the outside of the absolute value bar, we just keep it and our answer is negative. So let's scroll down. Let's see. We'll give this an erase and let's scroll down to the next part of the page. Move this out of the way. All right, so when adding integers, if the signs are the same, you add. But when the signs are different, you really subtract. So in my head, when I'm thinking about these problems, if the signs are the same, I'm going to add. If the signs are different, I'm really going to think about subtraction. So when adding integers, how do you know if your answer should be positive or negative? You know what? Just for the sake of time, I'm going to skip this part because we're going to get really into it when we get down here at these operations, okay? So what method do you use to turn subtraction problems into addition problems? We use this method called keep, change, but there are some other ways to really think of it. You can really think of it as adding the opposite, all right? Keep, change is a simpler way that a lot of kids like to remember, and a lot of teachers use it too. It's a helpful little device to memorize this. But whenever we do this, we're going to keep the first number the same, change the subtraction sign to addition, and change the following number's sign. So let's go down and do a few of these problems because it'll make much more sense when we see it in context. Negative 5 plus 8. So the signs are different. I have a negative plus a positive. So I'm really going to think about subtracting. So I'm going to subtract those numbers. And in my head, I'm really thinking 8 minus 5, kind of like back to elementary days, right? When you would put the bigger number first. So I get a 3. Now I have to think, is my answer going to be positive or negative? So this goes back to this question up here on number 10. Whenever I'm adding integers, if the signs are different, I keep the sign of the bigger number. The bigger number here is the positive one, 8. So I'm going to keep a positive 3. It's kind of like if you had a bank balance of negative 5. You put $8 in your bank account, you're going to be at $3, positive 3. So money is always a good way to think about these things because we all kind of have an understanding of that. Let's look at the next one. Negative 8 minus negative 2. That's a lot of negative numbers, a lot of subtraction signs. It's kind of confusing and overwhelming to look at. So whenever we see a subtraction problem, we always think, instead of subtracting a number, I'm going to use that keep, change method. I'm going to keep the first number the same. I'm going to change subtraction to addition. I'm going to change the sign of the following number. So now I'm going to rewrite it. This problem is negative 8 plus positive 2. And what's great about that is that we already know all the addition rules. The signs are different, so I'm really going to think in my head, oh, I better subtract. So I'm really going to think 8 minus 2, that'll give me 6. And I'll keep the sign of the bigger number. So the bigger number here is negative.
Again, we should be in first period at this time. You should be in your child's first period class. Thank you.
It's curriculum night, if you didn't know. So negative 6 is my answer. That's what I'm looking for. The next one, 6 plus negative 8. So different signs. Let me really think about subtraction. I'm going to subtract these two numbers and get 2. I'm not going to add them and get 14. I'm going to subtract them and get 2. And now I have to figure out is my answer positive or negative. Well, the bigger number here is negative, so I'm going to keep my answer negative, negative 2. Let's look at the next one, 13 minus 15, another subtraction problem. I'm going to keep the first number the same, change subtraction to addition, and change the sign of the following number. So 13 plus negative 15. Now I can use my addition rules. The signs are different, so I'm really going to think, oh, subtract them in my head. So I'm going to get some kind of 2, and is it going to be positive or negative? The bigger number here is negative, so I'm going to have a negative 2. 11 plus negative 7, different signs, so I'm going to subtract in my head and get 4. And I have to think, is my answer positive or negative? Well, it looks like the bigger number here is the positive one. So I'm going to keep positive 4. Over here, 5 minus 10. Let's use that keep, change method. I'll keep the first number the same. Change subtraction to addition and change the sign of the following number. So it's really 5 plus negative 10. So now I can use my addition rules. Signs are different. I'll think about subtracting. So I'm going to get 5. The sign of the bigger number, at least in this case, is negative. So I'm going to have a negative 5. So I'm looking for there. Down here, negative 1 plus negative 9. The signs are the same, so I'm going to add them up and get 10 and keep the sign from the problem, negative 10. Over here, another subtraction problem. Keep the first number the same, change subtraction to addition, and change the sign of the following number. So 12 plus 4, that gives me 16. Negative 3 plus negative 6, same sign, so I'm going to think about adding and get 9. Now I'm just going to keep the sign from the problem. They're both negative, so my answer is going to be negative. Over here, a lot of subtraction and negative signs going on, so we're going to rewrite this as an addition problem. Negative 7, change subtraction to addition, and change the sign of the following number. So instead of negative 3, I'm going to do positive 3. Now the signs are different, so in my head I'm going to think about subtracting. So I'm going to get some kind of 4. Is it positive or negative? The sign of the bigger number is the one we keep, and the bigger number here is the negative. So we're going to have a negative 4. Over here, negative 20 plus 1, different sign. So think about subtracting. So I'm not going to get 21. I'm going to get some kind of 19. The sign of the bigger number is negative in this case, so I'm going to have a negative 19. Once again, different signs. Think about subtracting. So I'm not going to add them and get 12. I'm going to subtract them and get 4. And keep the sign of the bigger number, which is negative here. Then down here, oh, absolute value of negative 2. Well, we just did that up there. It's positive 2. The distance from 0. So 2 plus 3 gives us 5. Over here, negative 8, the absolute value of it, minus the absolute value of 4. Let's do the absolute value part first. So the absolute value of negative 8 is 8. The absolute value of 4 is 4. I'll subtract them. 8 minus 4 just gives us 4. Over here, whatever is inside those bars, I'm going to do first. So negative 5 plus 7. So different signs. I'm going to think about subtracting. I'll keep the sign of the bigger number. It looks like the bigger number is positive, so I'll keep a 2. And now I'll take the absolute value of 2, which is just 2, positive 2. I'm going to go back and circle my answers. If you are not in that habit of circling your answers, I suggest you start. It's really helpful for your teachers and for yourself when you're looking through your work. All right, so that's the first page. We'll come back in another video and do the next page. All right.